Mindsetters, welcome to today's Maths Literacy Show. Today we have a special revision lesson on maps, plans and models. We have selected highlights from lessons shown earlier in the term to help you revise this term's work. So please post your comments and your questions on our Facebook page or on Twitter @LearnExtra so we can help you with your revision. You can also download the show notes for today's lesson from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
Here's the first question. It tells us, first of all, on a plan, the length of a wall measured 4,5 centimeters. Calculate the actual length of the wall if the scale of the plan is, and they give us a whole lot of things. So, you recognize these scales are different. What I want you to do, just as a thought, is think about it and say, on which one of these scales is the wall going to be bigger or smaller? Just have a gut feel. Well, Abraham, I tell you what, let's just do a little poll here. What do you think? If we know the reading is 4,5 meters, 4,5 centimeters. If the scale is 1 to 250, or if it's 1 to 1,500, which wall is actually going to be bigger?
It's the C one.
You think so?
Yes,
Are you sure?
I think so.
Okay, so the money's on C. Let's see if Abram's right, okay? Because we need to interpret what they're saying. It says 1 centimeter on the map is equivalent to 250 centimeters on the ground. Where this one is saying 1 centimeter on the map is equivalent to or represents 1,500 centimeters on the ground. Now, notice I used centimeters here, and I used centimeters in both cases. You need to know that in a ratio, if we're measuring meters, then the other one must be meters. If the one is centimeters, then the other must be centimeters. And they sometimes ask you to do a conversion as well. So bear that in mind. So how are we going to do it? I'm going to do the first one, and we're going to have a look and see. So the first one, I'm going to start with the scale is 1 to 250. And they tell us that the reading on the map is 5,4. That's the reading on the map. And we don't know what this answer is. We don't know what that is. So here's how I like to do it. And I want you to get a strategy. Don't get confused, bigger, smaller, multiply, divide. Just get a simple way that you can't get confused and you can't forget. So my way is to write down the scale, and I learned this from Peter, and underneath the thing that's saying the map, the thing that you start with, there'll be the 1. And you say to yourself, what did I do to 1 to get to 4,5? Well, that's not difficult to work out. To take 1 and get 4,5, I must have multiplied it by 4,5. 1 times 4,5 is 4,5. So how am I going to get to this unknown? What I do to the one side of a ratio, I must do to the other. So to get my missing answer here, I must do exactly the same. I must multiply by 4,5. Now, I'm not going to try and do that in my head. I'm going to say to myself, get my calculator out, clear the calculator, and let's start off by writing 250. And I'm going to do what it tells me. Multiply by 5,4. That was the number of centimeters that was on the map. So I'm going to multiply 250 by 5,4, and that gives me an answer of 1350. 1350. Now, guys, that's 1350 centimeters. So I started with a certain amount. I started with 5,4 centimeters, and I've ended up with 1,350 centimeters. So if I wanted to change that to meters, how would I do it? I would divide by 1,000, and I would say, well, that's equal to 1,3. Not by, I wouldn't do that. I wouldn't divide by 1,000, would I? Abram, you sleeping there? Correct me. Divide by 100. So it would be 13,50 meters. Remember, centimeters to meters, you divide by 100. Why? Because there are 100 centimeters in 1 meter. So 50 centimeters, if it gets to 99, it must become a meter. So look, there's the 50 centimeters. And if I move it up, then this must be reading a meter. So it's 13,50 meters. That's not a small wall, okay? Notice the scale was 1 to 250. Let's pick up the next scale. I'm not going to do the middle one. I'm going to do the last one, number C. And see how much bigger that is. Look at the scale. It's 1 to 1,500. So what am I going to do? Number C. I'm going to say 1 is to 1,500. And I want to know what is 4,5 centimeters on that scale going to represent. Look, I'm doing exactly the same process. I'm doing this deliberately. Multiply by 5,4. What am I going to do on this side? I must multiply by 5,4. Do it on the calculator. Clear that one. So 1,500 multiplied by 5,4. Now notice, this is 8,100 centimeters. 8,100 centimeters. So if I divide by 100, I'd get 81 meters. Okay? If I divide it by, so is that right? No, what would it be? Would it be 81? Yeah, am I right?
Yes, you're right.
If I divide it by 1,000, it would be 0,8. Hey, 1,000. Guys, what am I doing here? Centimeters to, that's right, I've got lost along the way. So let's just be careful. If we divide this by 100, I'm going to get meters, 81 meters. I don't want to divide that by anything else. If I wanted to go to a bigger unit, like a kilometer, I'd have to divide the meters by 1,000, okay, to get it into kilometers. But it doesn't ask me to do that, and that was just an extra bit. What I want you to now have a look at is look at the difference between, and this is just something interesting, and it's not something that we really need to worry about too much, but I just thought it was fun to look at. That was 13,5 meters. This one was 81 meters. Let's take the 81 meters, and divide it by 13,5 meters. So let's divide it by 13,5. 13,5. And what do we get? We get a factor of 6. Okay? Now, what's that saying to me? Hold on. Look at this. Look at this. If we take 250, which was my initial scale, that bit there, 250, and we take the 1,500, guess what? If I take 1,500 and I divide it by 250, what do you think the answer is going to be?
Nothing.
No, it's not going to be nothing. 1,500 divided by 250, it's going to be the same answers we got just now. 6. Okay, the thing that we measured was 6 times bigger on that bigger scale because the scale is 6 times bigger. Okay, so bear that in mind. So here's an interesting idea. We missed out number B. And some of you will be saying, but he didn't give the answer to number B. what's the factor difference? How much does 250 go into 500? Well, it goes twice. So what do you think the answer is going to be? Well, the answer is going to be that 13,5 times 2, which is, I must use my calculator, so 13,5 times 2 is equal to 27. So the answer for number B is 27 meters. You check it out and see if I'm right, but I'm pretty sure I am.
Okay, guys, I hope you're enjoying this revision session. If you are struggling and need help, please post on the page or send your questions to the Learn Extra Help Desk. The links are on our Facebook page. But now it's time to take a very quick break. Don't go away. We'll be right back. Welcome back from the break, guys. Doing revision is really important, so I hope you are enjoying this lesson. I'd love to chat to you on our Facebook page or on Twitter, so please let us know how you are doing. Enough of the chat, now it's time to get back to some more revision.
Now, let's move on to a real practical problem. I love these practical problems. I'm not a very good handyman, but I like to be able to see what's going on if I'm doing any renovations. Don't often do them. Here's a plan of a kitchen. And I think Peter's wife wants him to renovate the kitchen at the moment, and he's putting it off. That's why he went to Disneyland. So it tells us that all the doors are 90 centimeters wide. So there's a door, and I'm going to put that as 0,9 because it's 90 centimeters wide. And that one is also 0,9. And that helps me to sort out what the drawing's all about. So the first thing is we've got to do is to calculate the length of A. And guys, this is not difficult, but we're just simply reading off a scale map. We're reading off a map that's actually got a little bit of a bar scale there. So let's do the calculation and let's make sure we get it right. We want A. So you can see that it's 2,6 plus 0,9 because we converted it to meters plus 1,5, and we get the answer that this whole section is 5 meters long. Now, if that wall was 5 meters long, Abram, what would this whole wall be on this side? What do you think? Can we have a skew house?
No.
No. Look, this has got a 90 degree. That's got a 90 degree. You don't want your houses to be not built with 90 degrees corners, because unless they're round, they're going to fall over. The strength of your house, your foundations and pillars, is based on the fact that you've got these columns in place, and there's all sorts of forces involved. So we recognize that this is a square or a rectangle. Pretty much a rectangle because they're not equal size. So remember, that's 5 meters. This is only 4,5. So close to a square. So it means that that must be 5 meters. What we need to do is to find out the length of B. So how are we going to do that? You think about it. You got the idea? Well, I reckon the first thing I'm going to do is I'm going to add together the 0,9 and the 1,6. So I'm going to say 1,6 plus 0,9. I'm going to say that equals 2,5. So I'm going to mark on my drawing the bits that I've got. This is 2,5. And I know the whole thing is the green bit, which is 5 meters. So I'm going to say, let's start with the 5 meters. Let's subtract the 2,5, and it left me with the blue bit, which I can write down is also 2,5 meters. So B, this bit here, 2,5 meters. Okay, guys, I think we've got that one all wrapped up. Let's move on to the next one. This was just the introduction. This one gets practical. Tells us a carpenter wants to buy skirting. That's the stuff that you put around the bottom of the floor to make the meeting place between the wall and the floor look a little bit attractive. So he's going to use this in the kitchen, and he has to deduct the width of the door openings in order to do his calculations. So calculate the length of wood he needs for the skirting. Show all your calculations. So let's have a look at our diagram. Now remember, we have already said that that is 2,5 meters. We calculated that just now. And we recognize that that part there is 4,5 meters. We're not going to worry about the doors. So what we need to do is to add up. In other words, we want to find the perimeter. We want to go from there to there to there, from there to there, all the way around. Doesn't matter that there's a window. The window isn't going all the way down to the door, to the floor at least. Usually windows stop, and we're going to include all of that because we don't know the length of the window. I suppose if you were given this on a piece of paper, you could actually measure it using the bar scale. We're not going to go to that distance. So what's the perimeter? I think you can see that we're going to say perimeter is equal to 4,5 plus the 2,5. So I'm working clockwise around, plus 1,6 plus another 4,5. Now I'm going back up this way. I'm going to get plus 2,6. And I'm leaving out the doors because I was told to, 1,5. So it's kind of a perimeter without the doors, without the 2 bits of doors. Let's put that onto the calculator and see what we get. We're going to say 4,5 plus 2,5, which we worked out, plus 1,6 plus 4,5, and then plus 2,6 plus 1,5. And I get an answer of 17,2. So 17,2 meters. Now, just before we carry on, I always like to check myself. And checking myself doesn't mean doing the same calculation and hoping to get a different answer. That's called madness. What we try and do is we try and say, is there another way of doing it? So an alternative calculation is to say, well, we know that this was 5 meters from our previous calculation. So if I took 5 meters and I took 5 meters on that side, that would give me 10 meters. 4,5 plus 2 times 2 is 9 meters. So that gives me 19 meters. But now I've got to take away the 90 centimeters for the door. So 90 centimeters times 2 is 1,8. Agree? Abram, are you following me? If I subtract the 1,8 meters, okay, so take 19, subtract 1,8, and let's see what it equals. 17,2. Isn't that great? Yeah. I found another method. You see, guys, it doesn't matter what method you use. But as long as you explain what you're doing, and as I said to you, I think it's really a good idea to try and answer something in more than one calculation. Cool. Let's try and get this part of the question completed. At least it says the carpenter adds 12% to his measurement. What length of wood does he plan to buy? So now, guys, we want to add 12%. Now, I believe in doing things the quick way. So I'm going to show you the quick way of adding 12%. If I had 17,2 meters and I multiplied it by 1, what would I get? Abram? 17,2 multiplied by 1.
17.2.
If I multiplied 17.2 by 100%, what would I get? 17.2. Okay, so guys, I don't want to get less than what I started with. So what I've got to do is I've got to say I need 100 plus the extra bit. So that's 112. So I'm going to multiply this by 112. That's 112. That's the increase of 12%. Then I'm going to divide it by 100, which will give me my 12%. I've multiplied by 1,12, which is an increase of 12%, and it gives me 19,264. Round off to 2 decimal places, 19,26 meters. 19,26 meters. Okay. Now, here's his problem. The wood comes in 4-meter lengths. How many lengths must he buy? Well, it's not too difficult to see. If he buys 4 of these lengths, 4 fours are 16. He hasn't got enough. He's going to have to buy 5 because 4 fives are 20. And I'm not even going to do that. I'm going to say he needs 4 lengths of wood. You can do your calculator, but I'm moving
5.
to try and get the next one. It's 5 lengths of wood. Hey?
Yes.
Did I say 4? No, he needs 5. Because he needs to get to just a little bit under 20. If he gets too much, he's not going to be wasting too much there. Now look at what the next part is. And guys, this is always the type of question that's related to scale, it's related to this type of question. You're going to get asked a cost question involved. So 5 lengths of wood, what's it going to cost? You're going to say the cost is going to be equal to 5 times the cost of 1, and the 1 is 25 Rand 75, 25 Rand 75, and that's for 4 meters. I want 4 times 5, I want 20 meters. So I'm going to do that on the calculator, and look what I get. I'm going to say, clear that, 25,75 times 5 gives me 128 Rand 75 cents. 128.75 cents. Now this question should help you revise some sections of paper 2 as well, because it comes from the 2014 February paper. It's from question 3, and I've just adapted it a little. It tells us that a new shopping mall has opened in Roseville, and the layout plan as well as the store directory are shown in the diagram below. So there we go. Notice it gives us the north arrow. It also gives us the store directory here, the name of the stores, and there's the plan that it's shown us. Notice there's a key here that tells us these things are the mall entrances. These are the entrances to the shops. These are the doors to the mall. Those aren't very clear, but they're between here and there. There's one, there's a door there, there's a door, all at the entrances. Now, what does it say to us? First thing it tells us, Peggy wants to buy gifts at Hallmark. So if we look on the store directory, we'll see that Hallmark is over here. It's shop number 5. So let's highlight where Hallmark is. We know that we're going to have something to do with Hallmark. There's Hallmark. So it's the blue one. Describe the route she has to take from Cafe Teen to walk to Hallmark. So have a look here. How are we going to do it? She's in Cafe Teen. We need to describe the route. So I'm going to draw it and describe it as I go. So if she's inside the Cafe Teen, the first thing is she's going to go to the entrance. She's then going to turn to her left. Is that right? Make sure you know the left from the right. Your left, your right. Make sure you've got it correct. And so she walks past out of the store. She turns left. So the first thing, she must turn left. And then when she comes to the end of the shop, she must walk towards the fountain. So she heads in a north direction. She turns left and walks north. Walks north towards the fountain. Okay, when she passes this into this courtyard, what's she going to do? She's now going to turn right. And she's going to go past shop number 9, and she's going to go towards shop number 8. But then she's going to turn left again. And she's going to carry on all the way past entrance number 2. She's going to go straight past entrance number 6. Oh, sorry, shop number 6, the entrance to that. And if she goes straight, she'll find shop number 5 is where she is. Now, when you write it out, you need to put down all the key facts, all the shops she's passing, so that if somebody were to follow that route, they would know exactly which way they were. You can put it in bullet points. Each step, do this, go that far, go this way, go that way, and put the highlights in. If this was a scale drawing, then you could even indicate the distance. But on this stage, we don't know the scale. We haven't been told any measurements, so we've just got to give them in the direction either of left and right, and you can combine it with north as well, because your compass needle was put over there.
I think it's time for a break now, so don't go away. We'll be right back. Welcome back from the break. Let's not waste any more time and get straight back to today's revision lesson.
Now, the next part, we're given a floor plan. And here is a calculation that we're needing to do. It's an odd-shaped store in that the sense that it's not regular. And what we're asked to do is to calculate the total floor area of the store. This is of the Hallmark store. So you can see it's not a regular shape. So how are we going to do it? It tells us, the examiner is very kind, that you may use the following formula. We don't have to use all of them, but it tells us you can use the area of a rectangle, the area of a triangle, the area of a trapezium. That one isn't often used, and maybe you haven't used it before, but here it is, and there might be a chance to use it. So let's have a look. The first thing we're going to do is we say, well, we haven't got any rectangles. We haven't got any squares. We haven't got any triangles. We haven't got any trapeziums. Because remember what a trapezium is. A trapezium has two sides that are parallel to each other. And so this side is parallel to that side. This side is parallel to that side. And these are not parallel. That side and that side are not parallel. So it's kind of like a squiff or a skewed rectangle-ish kind of shape. Rectangle with a triangle onto the end of it. So that's that. Now, can you see a trapezium here? I hope you can. If I draw a line across there like that, I hope you can see that that section at the bottom is a trapezium. But you could also say to me, hold on, John, if you take your line over here and you go from there to there, then you will also get a trapezium. You will also get another shape. It's not a trapezium, but I think it's a shape we can work with. So have a look at that, and what you should be able to see is that we've now able to divide our things into rectangles and triangles. So you've got, look here, you've got one rectangle, two rectangles, and number 3 is the triangle. So we could use the formula and calculate both the rectangles and then the triangle. But you know what? I really like the idea of doing the trapezium. So let's start with the trapezium. If there's time, we'll come back and do the triangle and the rectangle. So the first thing I'm going to need to identify is what's the length of the rectangle of the one side. Well, we've been told the length of 1 is 13,9, because the green line is the same length as the one that's parallel to it, the one up there, 13,9. Side 2, the length of number 2 is 5,8 meters. They're both in meters, so we're fine. Now, what we need to do is we need to find from the formula it tells us that what you need to do is to find the sum of the parallel sides and multiply it by half, and then multiply that answer by the height. So let's do that part first. So we're going to take on the calculator, pick this up and say 13, don't go to 13, 9 plus 5, 8. Add those two together and then divide the answer by 2 or multiply by half, and that will give us the average. So I'm going to take that as the average of the parallel sides is 9,85. So the average of the sides of the lengths is 9,85 meters. Right. What next? We now have to take that part of the formula. We've dealt with that part up to there. We need to multiply it by the height. Oh, let's do that. Notice something here, that this whole height is given as 10,4. And this little bit is 2,3. So I reckon that the height of my trapezium is what's shown in the pink line there, must be 10,4 minus 2,3. Now, even though it looks easy, I'm not going to do it in my head. I'm going to use a calculator. So I'm going to say to myself, 10,4 minus 2,3. Don't make a silly mistake and get it wrong. We say that's 8,1. So the height is going to be equal to 8,1. And what do we now have to do to get the area? That's what we want, the total area. We want to take 8,1 and multiply it by the average length, which was 9,85. Multiply that together and we get the area as being 79,785. Round it off to 79,79. So the area is equal to 79,79 meters squared. Don't forget to put the units in. And obviously, I didn't set it out because I was just working next to the diagram. Didn't set it out as neatly as I could. You could do some rough working. But when you get your once you put your final answer, scratch out all that rough working. Just put a line through it and then set it out neatly. So you're going to put in the area of the trapezium. And I'm glad I did think before I finished. You're going to write down area of the trapezium. And you put down the formulas is equal to half the length L1 plus L2 times H, all the words they've given you. You substitute in, and I'm not going to redo it, and that will give you the area of the trapezium. Now, what did they say? The total floor plan. So we've just calculated the area of the trapezium. Remember where the trapezium is? It's this bit here. It's parts 2 and 3. We've still got to calculate part 1. So now let's do part 1, which is the area of the rectangle. And I'll set it out nicely for you. The area of the rectangle is equal to the length times the breadth. And what was the length? Look here again on the diagram. The length of the rectangle, 13,8, and the height, or the breadth, 2,3. 13,9 times 2,3, which was the breadth. Let's put that together into our calculator and get the calculator up. We mustn't forget 79,79. Let's put it in. 13,9 times 2,3. Let's see what that gives us. That gives us an area of 31,97. 31,97 meters squared. Check the meters are all in meters. Now, guys, therefore, the total area of the shop is equal to the area of the trapezium. It's the trapezium plus the rectangle, which is going to give us trapezium 79,79 plus 31,97. And let's do that on the calculator. We're going to say plus 79,79 equals, my final answer is 111,76, 111,76 meters squared. And there we've got it. We've set it out, we've thought it through, and we've got the right answer. Now, I've got 2 more questions, and I'm going to do this one next. In fact, I've got 2 whole questions. This has taken a bit longer than I thought. Let's finish this one off, and we'll see if we can do the others later. So the hallmark entrance has got a security curtain gate. It tells us the mass, excluding the frame. The mass of has a mass of 4,7 kilograms per meter squared. The material that is used to make up the curtain, excluding the frame, costs 12 Rand 50 per kilogram. So what do they ask us? If the dimensions of the curtain gate, excluding the frame, are 3 times 4 meters, determine whether the cost of the material to make the security gate exceeds 800 Rand. Now, let's have a careful look at this. First thing that we need to work out is what the mass of this curtain gate is. How are we going to work out mass when we've been given dimensions of length and breadth? But you know what we've been told? We've been told the mass per meter squared. So we're going to work with that. First thing I'm going to do is I'm going to, let's say, calculate the area. And the area is the length times the breadth, and I can get that from previously, which is 3 times 4, which in this case I think we can write down as 12 meters squared. Now, to get the mass, what I need you to understand is we were told over here 4,7 kilograms per meter squared. 4,7 kilograms per meter squared. Per meter squared divide by kilograms, divide by meter squared. And I'm going to multiply that by 12 meters squared. Now look what happens. The meters squared cancels with the meters squared. And what do I get left? 4,7 times 12. The units are going to be kilograms. So I know that I've got it right. So let me put it together, and then we'll get the answer. 4,7 multiplied by 12 equals 56,4 kilograms. Now, was that what the question asked me? No, look at the question again. It said, does the cost of this gate exceed 800 Rand? Well, how are we going to work it out? Well, we know what the cost of 1 kilogram is. It costs 12 Rand 50 per kilogram. Let's work out what the total cost is. So the total cost is going to be the price per kilogram. It's price per kilogram times the kilograms. Now look again, what happens? That cancels with that, and we're left with the price. So let's do it. We're going to say 56 kilograms. I've put it in the wrong place. Let me put the 12 Rand 50 there so it was in the right order. 12 Rand 50 per kilogram, and that's a Rand, and there's a kilogram underneath, and we were told this is 56,4 kilograms. Now look what happens. Kilogram cancels with kilogram, and all we need to do is to put those numbers onto the calculator. So 56 we've got. We're just going to multiply that by 12 Rand 50, and look at my answer. The answer is 705 Rand. Is it less or more than the 800 Rand? Can't leave my answer there. What did it say? It says determine if it costs more than 800 Rand. And so you're going to have to answer at the bottom of this, having worked it out, you're going to say, no, the cost is less than 800 Rand. And that would be the right answer to get your full marks. Let's take a look at question 2 quickly. I'm not going to do all the working, but I want to just do some of it. And I really want to do question 3 as well. So let's fly through this and see. Gail makes pencil holders as gifts, and she can personalize them. There's the type of Mr. Khan decides that he wants to use these pencil holders for end-of-year gifts. He wants to order 46 pencil holders for the staff at his school. So the cylinder, a pencil holder, has a diameter of 10 centimeters and a height of 15 centimeters. The first question is, how should Gail pack these pencil holders? Now, she's got to put in 46 of them. So how is she going to pack them? Very important thing to think about. Now, guys, you don't want a huge big box with these 46. One box to carry 46. 46 isn't a very nice number. And remember, they're cylindrical as well. So how are you going to pack them? Here's what I think a possible solution will be. If we take 40, and we recognize that if you divide 8 into 40, you get 5. So what we could have is we could have 5 boxes that have 8 in them, 8 cylinders in them. So think about it like this. You could have them standing up in the box, and there would be 5 of these. Got it? And that would make sense. The box would be the length of this, would be, you could work that out, it would be all of those added together and that added together. Would fit in 8. Be nice and comfortable. Of course, you could make it a double-decker box, and you could have 4 of them lying down and 4 of them on top. Be slightly shorter, but slightly bigger, or higher. All of those are possibilities. So that would take care of 40 of them. What about the other 6? Well, that wouldn't be too difficult. You just get a smaller box, and you put the other 6 into that box. Okay? So there we got the 6, and we are going to take 6 into that box like that, and there you've got your 46. Now, guys, there are numerous solutions. That's just one suggestion. But if you show your working and you sketch it and you put it together and you give your reasoning, there's no reason why you won't get the full marks. So that's one way of doing it. The next thing is she's asked to calculate the volume of polystyrene she needs to fill between the gaps. Now, if she's wanting to protect the mugs, yeah, she might need to add some polystyrene. So what are you going to do? You're going to need to calculate the volume of the box and then the volume of each of the cylinders and multiply those together, volume of the cylinder multiplied by 8 or multiplied by 6, and then subtract the 2, you get the volume, the spaces in between. You want to fill that with polystyrene so it doesn't knock around too much. Okay, so that's how you would do it. I'm not going to have time to do that calculation, but I wanted to explain how to do it. So let's move on to the next one, which is kind of similar, but it's on our theme. We're missing Peter so much. Are you missing Peter?
Yes.
Oh, we do miss him. He brings a fresh light to the studio when he's here. And we're going to enjoy his jokes when he gets back as well. So here's question number 3 that's all about Peter and on that long trip back to South Africa from the United States. And so Peter is very uncomfortable in his small seat. You know those airline seats? They can be really small. And you've got to sit there for hours and hours and hours. The flight, they're flying from Florida or from New York all the way to England, and then from England, from London, back to South Africa. So it's hours and hours, and you can't often sleep. It's a long time. So he can't sleep. So he takes because he can't sleep, he takes some measurements of the airplane he's flying on, typical of a maths lit teacher, probably looking for an exam question, and he starts to do some thinking about the design of the seating arrangements. So there he is on his plane, and instead of watching a movie, what's Peter doing? He's doing some calculations, typical of him. And here are the facts he finds. Look at it. The interior cabin width is 5.86 meters. there are only, the seats are only 375 millimeters wide. For safety, the aisles need to have a minimum width of 375, the same as the seat. And we're told there are 2 aisles on Peter's flight. He notices the plane is only 80% full. Now that information is going to be important when we come to the calculation. So it now says, draw a sketch to show the maximum number of seats you can fit into one row. So how are we going to do that? Well, before we start sketching and go wild, we know that's the width, and we know that's the width of the seat. So I guess we need to convert to the same unit. So we're going to say 4,86 meters is the total width. That's the total width. What's the seat width? 375 millimeters. To convert to meters, I'm going to divide by 1,000. So that's 0,375 meters. I want to know how many of these things fit into that distance. So what I'm going to do is I'm going to take the calculator, I'm going to clear the calculator so you can see, and I'm going to say 5,86 divided by 0,375. Check it. Yes, that's right. How many times will it go in? Now, it tells us it's 15,62. So that means that we can fit 15 whole units, and there's some leftover space. So we can fit 15 altogether. So 15 whole units. But guys, can we just put seat, 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 seat? No, we need an aisle. And there were 2 aisles on the flight that Peter was on. So let's keep the 2 aisles. So if we take away 2 from that, that gives us 13 seats. 13 seats will fit into that space. So we've now got 13 with 2 aisles, plus 2 aisles. Okay, so how can we fit 13 into a row? Well, I suppose we could do, that's what they were asking, a sketch. 1, 2, 3, 4. That gives me 9 left. Let's have 6 in the middle. 1, 2, 3, 4, 5, and a 6. And then on this side, I'd be left with 1, 2, 3. So on this side, I've got a configuration of 4 plus 6 plus 3. Now, if you think about it, it does kind of make sense, because somebody coming down the aisle that's going to serve food can serve 3 people that way, 3 people that way. On this side, they're going to serve 3 people that way, and 4 people that way. This one's a little bit clumsy, not so good. Maybe you could have had 3, 7, 3. That would also work. But to serve that person in the middle, passing the food along, maybe not the best idea. Notice that the aisles here would be wider because it was 15,06. But that's the configuration that we've got. Hope you can see that packing arrangement. Now, what's the next part of the question? Let's go on, because Peter's not finished. Because he's very uncomfortable in his very small seat. And you can understand, for somebody like Peter, you need a bigger seat, a wider seat. So he would like a seat that is 46,2 centimeters. So the question is, how many of these seats could you fit into one row? So we're going to apply the same thinking, and we're going to say, remember our interior of the cabin, 5,86. 5,86 meters, and it was 46,2 centimeters. We're going to change that into meters, 0,462, and we're going to do the calculation. So we're going to say, let's scrub that. We're going to say 5,86 divided by 0,462 equals, how many is it going to be? Well, there you go, 12,68. 12,68. Only 12,68. And guys, we haven't considered the aisles yet. Okay, so we recognize you're going to get fewer in the row. That was obvious. But let's work it backwards. Say, well, is it possible if we take one less, we take 11, and we'll give one seat to the aisle plus the 0,68 part. We'll put that into the aisle. Let's see if that will work. So I'm going to work backwards now and say, how wide would 11 be? Now remember, how wide is 11? 11 is going to be, we'll just see if it works. 11 times 0,46, 0,462 equals, that gives us 5,082. 5,082. Now, let's see what's left over. So the leftover, that will be all the seats. That will be the seats. And what we're going to do is what's left over, we're going to take our original thing of 5,86, and we're going to minus 5,082 from that, and we'll see how much we've got. If we've got enough room for the aisles. So I'm going to do something here. I'm going to say, let's take ourselves 5,86 minus 5,082, and that gives us this answer, 0,778. We divide by 2 because we want 2 aisles, and that gives us an answer of 0,389. 0,389 meters, which is 38,9 centimeters. Now, what was the safety requirement for the aisles? The aisles had to be 375 millimeters. Go back to here. Look what we're saying. 389 millimeters. So the aisles are wide enough. So yes, we can fit 11 in with 2 aisles that are slightly wider. Isn't that great? That's an amazing thing to do. Last point. Why doesn't the airliner give bigger seats if the average occupancy is 80%? So guys, here's the question. We could have 11 versus 13. And the easy way to look at this is if we say, what's 11 out of 13? So we could have 13. If we only have 11 divided by 13, then what's that? 11, 13 as a percentage multiplied by 100 gives us 84%. So we would have, you could go for bigger seats because you would be able to get 84% of the seating capacity. We only need 80% of the seating capacity. So, in fact, Peter should write a letter to saying, guys, give me bigger seats.
We've come to the end of today's show. Thanks for joining me and for chatting to me during the show. Please visit our website, learn.mindset.co.za, to get the notes and to watch the videos from earlier in the year. And remember, we are here to get you through the year, so stay connected. Goodbye.